Awesome. I'm here to talk about making software to make software, which is, a deliberately recursive topic, I guess. So a little bit about me and about this talk, I guess. My name's Greg. I am the head of software engineering at IC Plant. I think most of my engineering team's here today. Thanks, guys. So we're a relatively small engineering outfit based in Fortitude Valley. There are 6 of us in the team. And we do like some pretty cool things at the kind of speed that kind of belies the size of the team. So full DevOps operation, continuous deployment to production, 20 plus deploys to production every day, loads and loads of automated testing. And this, I guess, is a talk about, in part, how we go about doing that. One of the things I find really, really interesting is that most people who write business software, our job is to build systems that improve the efficiency of other people, either our customers or the staff we work with. I mean, if you're writing video games, that may not be true, but for the most part, we're building software for other people to improve their efficiency. And in a lot of cases, we rarely kind of see software engineers apply that same mentality to their own work. And there's a lot of procedural work that we do day to day. But most of the time, we just settle for what the framework gives us in terms of local development environments or what the particular tool chain we're using is giving us in terms of automated testing. We don't go much further than that. About 2 years ago, we started going a fair bit further than that. And that's kind of what this talk is about. And hopefully give you some ideas to encourage you to make similar changes in your own organization. I'm not going to give you any code in this. And that's kind of on purpose, because this is really context specific to the kinds of problems that we face. And you will all face very different problems. But you can take the ideas and hopefully put them to good use. So I've got this sort of 4-box thing. We'll keep referring to it. These are the sorts of problems that we face, kind of really boiled down into a really simple 4-box. We have infrequent and complex work. So stuff that happens once every month. It's pretty hard. We have frequent and complex work. It's hard to do. We do it all the time, though. And that work we usually discuss with each other. We all know what's involved in doing that. For some people, that might be deployment. We all roughly know what deployment looks like in our organizations, but there's probably a bunch of steps that are part of the verbal history of the team that go with that. Then we have infrequent and not complex. And I've got this. And frequent and not complex. So infrequent, not complex work, don't even bother about. That's the kind of stuff where it's so simple that you're likely going to just reconstitute the knowledge every time it comes up, because it only comes up once a month, and it's really, really simple to reason about. Frequent and not complex is probably where most of your tool chain currently sits, running PHP unit tests. That is not complicated. You do it all the time, and you've got existing tools there. Where we'll probably spend a lot of the time in this talk is in that infrequent and complex and frequent and complex space. And the idea is to try and pull some of these things down into other boxes. So this is kind of a tale, starts as a tale about local development primarily. We have a complicated architecture. It wasn't always complicated. It used to be very monolithic. You'd create a new project by doing composer create project Laravel. You would onboard a new staff member by saying, Git is over there. Pull Git down, run composer install, and you're good to go. We now manage more than 30 services. The services are all interconnected. They communicate with each other via OAuth tokens. You need to have some mechanism of getting them to communicate locally when you're developing. So if you want to load up our main web page locally while you're developing it, it pulls information from a content API. It needs to get a token from a login API in order to be up to the front end of the CMS can talk to CMS can talk to each other. It's pretty complicated, and the complexity spirals as you add more and more services to the mix. To make matters worse, Laravel gives you 3 options for local development. It gives you a thing called Laravel Valet. So if you're a Mac user, you can run everything on a Mac, including trying to figure out how to get different versions of PHP to run on a Mac, which is often not trivial. You can run Homestead, which is a vagrant virtual machine setup, where you have one virtual machine and all of your projects live in that virtual machine and you talk to the virtual machine. And then sort of most recently, I guess, they've got Laravel Sail, which is doing the same thing that Homestead did, but doing it with Docker. So it's kind of abusing Docker is the way that it tends to work. We used all three across the team. People basically chose what they were comfortable with. Most of us were using Homestead. And we started treating, does anyone heard the phrase, you should always treat like local development as cattle, not pets? We were treating them like pets. So someone would find out something's going wrong with their Homestead. They'd do a bit of Googling. They'd realize they've got to put some arcane config into the Nginx config to make it all work. They'd do that. Their local development environment would keep working until they needed to upgrade. Then they'd upgrade and it would break in ways they weren't expecting and couldn't remember how it broke. Or they'd have other people in the team would be running into the same problem and that knowledge wasn't able to be quickly spread amongst the team. This really manifested for new starters. So as the architecture got more and more complicated, the onboarding of new starters got longer and longer and harder and harder. So we looked at tackling this from a new starter perspective. And the way we went about doing that was we decided to standardize on Docker. Initially using Sail as a base, we've now completely moved away from Sail, except for maybe the underlying basic Laravel container, but everything's basically individually containerized. And we boiled this down into a single command. So once a new starter has a Bitbucket login, so they've got access to the repositories, they type one command into their computer and it will set everything up for them. It will do all of the machine dependencies that are required via brew. Looks a little bit like this. So we install brew dependencies, we clone all the repositories, we do all the vendor dependencies, we build all the projects. We run a Nginx proxy so that you can actually access these containers. That all gets set up for you. It even sets up local HTTPS certificates, which is great. If you never having to, in a local development, never having to go, yes, I accept the security warning for not having a, never thought that would be the thing that I love the most about this, but it actually really is. It also grabs snapshots of production data where that's appropriate for our particular stack, pulls all of that down, runs up local databases, configures local testing databases. Then it sets up a local user, it sets up Laravel Passport, which is the OAuth layer, and then tells all of the services that it's just installed, here are your keys to talk to all the other services. And at that point, you can run tests, or you can go straight to your browser and open something up, and it will just work. So we've taken a new starter onboarding process that was taking a couple of days, and depending on network connection, turn it into less than an hour. And that's kind of the gold standard for us. Can we get somebody online in an hour without having to go and futz around with the local development environment? For the most part, we're there. Breaks occasionally, but it's software, so don't get it wrong. There's also Star Wars memes all the way through it because, of course, there is. I really wanted to get the like a really high fidelity ASCII art Death Star. If anyone's got one, I will put it into the local development environment. So this has some really interesting knock-on effects. So we take something that's infrequent and complex, and then we make it frequent and not complex. So now we treat our local development environment as cattle, not pets. So if I've got people who are working on one part of the code base and people who are working on another part of the code base, and they're working in semi-isolation for a couple of months, so overall the code base is drifting, rather than at the end of that project having to figure out how to bring all the local development environments back up to scratch, you just delete them, run it again, build the whole thing from scratch, and it's exactly the way that it needs to be at that point in time. So that's been a really great efficiency gain. Didn't seek for this to be an efficiency gain. We just ended up landing on that because we fixed the new starter problem. Adding new services. So again, when we sort of started doing this, adding a new service was a case of composer create project, Laravel, name of new service. Hey, we've got a whole new Laravel up and running. In a sort of complex service-oriented environment with a whole bunch of automated testing and so on, there's a bunch of other things that go with creating a new project. We need a build pipeline. We need Git hooks to manage, to enforce coding standards. We need to make sure that we're using all the sort of libraries we've all agreed to. Our corporate style guide, which is a Tailwind config file, needs to be installed, which means we need Tailwind. We run a React and Inertia stack on top of Laravel. That all needs to be built in and configured. So again, with a single command, we can create a whole new project. And that step will actually reach out to our CI account in AWS, set up a build pipeline. It'll set up everything except Vapor deployment because we haven't quite gotten to automating that yet. But in theory, you can. The idea here is to get to make me a new project and then deploy it and do that in one step. So I don't have to remember. We don't have to have this shared understanding and knowledge across the team about remember to make sure that you're installing the corporate style guide and remember to make sure that you're using this version of whatever library we've agreed to use. So it's taken something that was infrequent and complex. It's still infrequent. We don't necessarily want people just going willy-nilly and making services every day, because it's a whole other different class of problems. But it does mean that creating new services becomes a string in a developer's bow, instead of going, I've got a new feature, can I awkwardly fit that new feature in an existing service, because setting up a new service from scratch would be too painful. Attaching the new services to an environment. So if somebody's created a new service and I don't have it locally, again, this is a case of git clone, run a command, and that service, I will then have that service locally. It will set the Docker container up. It will configure the Nginx proxy. It will set up all my etc. hosts. It'll do all of that stuff for me from a single command. So that takes something that happens frequently and was reasonably complex, and means it can happen frequently and be just trivial. Tailing logs. This is a really good one. Because all these services communicate with each other, you have a request come in, and then you want to see what's been happening across the entire service stack. We have a command that'll, this was just visiting the homepage on my local computer this afternoon, which is in a bit of a broken state. But I can see every service and request, and I can view those logs sort of in one pane of glass. It supports tail and filters and all sorts of stuff as well. So, setting up profiling tools. Profiling is often hard. We kind of have a turnkey profiling solution that I think uses Laravel Profiler. You run a command, you get a profiling container, you run another command to start profiling the thing that you want to profile. You run the page you're interested in profiling, and then you've got a full view of that request across the entire stack in a single pane of glass. Another one is AWS config for CLI access. We have a multi-AWS account set up. So we have 7 AWS accounts for various different workloads. Some of us switch between developer and administrator roles. This command basically just sets up the AWS config for you, which means that a lot of the other tools that are reaching out to AWS can just look at that config and use the underlying AWS CLI without having to manage the AWS config file and remember whatever arcane knowledge you need to know to make sure you're putting the right credentials in the right place. ngrok. Anyone use ngrok? So we can share our local development environment instance with anybody by creating a tunnel. ngrok will do that for us. It's actually like pretty tricky to set up in some cases. Single command, you've got an ngrok endpoint. We actually have this specifically set up for our communications platform, which is built on Twilio. Usually the way that works is when a phone rings, Twilio reaches out to us with a webhook. Using this and some more local development magic, we can inject config into Twilio so that Twilio will call an ngrok endpoint when a particular phone number rings, which means we can debug our comm system without having to deal with Twilio logs, which are a nightmare. So this is not really a frequency problem. This is more a taking something that's painful and usable and making it painless and usable. So some of this is about reducing developer pain and enabling developers to do things in a way that makes their lives a bit easier. Our tool will also set up pre-commit and pre-push hooks. And it'll do this anytime you run any of our commands. It will then check all the repositories you've got checked out and inject all of these hooks. It's actually quite painful to undo that. You delete them, then you run another command, and they automatically come back. So these hooks do things like run the linters and run unit tests before pushing. Another thing it'll do is it'll reach out to our CI dashboard and request the current code coverage for a particular project before push. And it'll compare that against the code that you're about to push. And it'll sort of say, you're reducing the overall code coverage by an amount that we've agreed isn't acceptable for that project, and it will stop the push from going through, which is like a way of enforcing that. We do let code coverage slip. We're not sort of code coverage Nazis or anything, but if somebody's introducing a feature that drops code coverage by 10%, that's probably not a good thing. They're dropping it by 1%, maybe it's okay. Just break your pull request up into 10 pull requests and reduce it by 1% at a time. It'll be fine. We use a little bit of DynamoDB, not a ton. So we use local stack, which is a collection of I'm going to get this wrong. Ben's on the call. He can correct me. But local stack's like a collection of Docker containers that give you simulated bits of AWS that you can run locally. So this is basically a wrapper around Redis. But our code doesn't know any different. So we can sort of have local DynamoDB running, which is handy in a number of contexts. Not that we've seen, but again, we're not using it extensively. So I'm not sure that it's like 100% feature parity with DynamoDB.
Some of the features are, not all of them.
So yeah, the overall benefits here really are, I guess we've gone through most of them, but the idea that we can have a single central set of tools that matches our particular use case and our context and unlocks our developers to spend more time building value for the business instead of wrangling a code base is pretty key. I think on the next slide, I can actually quantify some of that. So it's a logarithmic graph, so these can be a little bit funny to look at. But we sort of started doing this at around the beginning of 2021. And we've reduced the average cycle time, so the amount of time it takes for any given ticket to go from work started to deployed in production. We've reduced that from 20 or 30 hours to 2 or 3. So that's on average. There are definitely outliers. There are tickets that take hundreds of hours to do. That still happens. But on average, we're able to deliver features faster because we're not spending as much of our time, trying to wrestle with making sure that local development has a current database schema that matches, what this service I haven't touched in 6 months expects. It's just kind of all there for you. Yeah. So in terms of what's next, there are a bunch of things that we want to add to this. We want to add more local stack. So we have a hand-rolled event bus solution. Don't do that, anyone. If you're going to use an event bus, use EventBridge, but this kind of predates EventBridge, so give us a pass mark for that. We're going to use local stack SQS and SNS so that we can debug that locally, which is going to be cool. Another thing is that we haven't yet mapped it out, but each service effectively understands what its dependencies are. So we can create a graph that sort of says, if you want to run the front end, these are the services that you need, and these are the services that those services need, and so on, which means that when you pull a local development environment down to work on a particular project, you're only getting the bits that make sense. We all run Macs. Docker on Mac is... it's pretty good on an M1, but...
Not too bad. It's really nice.
Well, yeah. It's...
It really is.
On an M1, it's about, I think it's about 40% slower than running the stuff on Metal on a Mac, but running it would still be like 100 times faster to run on Linux, but whatever. And so reducing the amount of weight of the local development environment by sort of graphing out what the dependencies are for a particular service are one of the things that we're actively looking at as well. But effectively what we're looking at is any of these, particularly the infrequent, I think the real killers are the infrequent complex processes in the team. The frequent complex processes, you will fix them because the pain is just happening all the time. So you're either going to get Stockholm syndrome or you're going to have to go back and fix those problems. But the infrequent ones, the ones that happen once a month or once a quarter, we're actively looking and have actively been looking at rolling into this. Some lessons learned. Not too many. I don't want this to be like super preachy. We've done this twice now. We did it twice in the space of about 3 months. And the first thing we did was we thought, let's build a collection of bash scripts and make files. And only 2 people in the team really, really understood bash and got really, really clever with what they wrote. We actually found that writing in the team's lingua franca was the most important part about getting this off the ground. So we use Laravel 0, which is effectively just the console component of Laravel. But if you're using Symfony, just use Symfony components and just write your own tools. We have some pretty thin wrappers around Docker. I know every developer should eat their vegetables and learn Docker, but really going up to every developer and saying you need to learn Docker in order to run this, it doesn't work. So the people who do know Docker have written some very thin wrappers around the bits of Docker that we use. Those thin wrappers are written as PHP classes that reach out to the CLI via the Symfony process component. And then everybody can contribute to the project. You're not limiting who's making contributions. If somebody feels some pain, they don't have to go to the bash wizards and say, this is hurting, can you please fix it for me? They can fix it for themselves. And on that too, I think you need to adopt an internal open source approach to this. This again will not work, I don't think, if a small team within your team is mandating the use of these kinds of tools. Everyone has different pain points, even within organizations as small as ours. We have different people experience different kinds of process-oriented pain. So open it up, let everyone in the team contribute, let everyone do for the engineering team what they do for every other team in the business. And I guess the last point is that you need to find time to carve out for this. It's very hard to make the case sometimes to businesses that, hey, we want to take 20% of the next 2 months to work on local development tools. We've 10x'd our productivity by doing that. So relatively small investment, massive payoff. And overall, the developer happiness is a lot better. I guess the last point too is that you should probably think that if you're writing documentation, write it as code. Most of the documentation for this kind of stuff is run this command in the console. It's very, very easy to take that and turn that into something that's executable. So executable documentation is effectively what these tools end up being. Yeah, that's it. So yeah, questions. How do I do for time, by the way?
Good. Perfect. Good.
Questions? Yeah.
How did you go? Did you have any issues getting everything running okay with the Apple Silicon?
Yes, it kind of mostly worked. We ran into some issues with an Elasticsearch container I think we were using like the official Elasticsearch container, which for the version of Elasticsearch we were using wouldn't support and will not support Apple Silicon. Hopefully somebody in the community has compiled one that will, so we don't have to introduce breaking changes by rolling up like 3 majors on Elasticsearch, which is great. But yeah, by and large, it mostly just works.
Generally, the Mac Docker performance is like far worse across everything. So it's like that one that's running still on like the Rosetta emulations.
Well, actually, interestingly, there was a recent update to Docker for Mac can now like transparently reach out to the Rosetta layer.
Yes.
And oddly, on certain workloads, running x86 code in Rosetta is faster on an M1 than running it on the fastest like x86 chip because reasons.
Yeah. File system is still really slow.
Yes, well, there's a file system extension now too, which is virtualis is like pretty quick. It's not like if you've got a massive
benchmark to like Linux.
Sure. And I mean, if you've got something that's incredibly IO bound, then just use Linux. We use Macs, but you know it really shouldn't matter what your standard like hardware is. The theory would still hold regardless.
Yeah, we had to. I was running on Linux with a Java container. It runs an API for the project I'm on. It runs 10 times faster on a Linux machine than it does, and that's booting in Docker, than it does on the Mac. And you're the reason why I bought my Mac MX2 Pro. But I like it. But you know,
I'm the reason. I'm to blame. I held the gun to your head.
You demoed some stuff to me because I was very questionable about that because I've been on Linux for such a long time and I'm like,
it's my fault, guys. I'm sorry.
I don't mind it. It's okay. I like the environment, but Linux is still a shit ton faster.
Sure.
On that though, then this setup's like all Mac only, right? Like
well,
tooling like the scripts you've got at least.
Well, the only part that's probably really Mac centric is the fact that the first 2 things that it does is it checks to make sure that you're not running, you don't have an open IDE because of the way that auto saving in PHP Storm works can cause merry hell with certain things. It's sort of, if you try and run it while PHP Storm's up, it'll say stop that, and it's using whatever Apple's version of top is, but you could rewrite that for whatever you wanted. And then it's the brew dependencies because there's like a local DNS like management component that installs, and there's a thing that allows us to programmatically talk to the keychain on Mac. I mean, you could, if you had a mixed environment, you could very easily like figure it out whatever you wanted to. You probably run into similar kinds of problems though, depending on the flavor of Linux you're running, right? So you're going to be are you using Yum or are you using apt-get or whatever? So
did you look at remote development environments?
Yeah, so we looked heavily into that. We looked at JetBrains' offering. We looked at GitHub's offering and just found the latency was like horrifically bad for us. It could have been our internet in the office, but also the cost was fairly high. I know you can get really like you sort of pay for computer. You can burst that up if you're not paying for having the computer hanging around all the time. But yeah, we just the cost didn't work out for us, and the sort of developer experience wasn't as great. There's definitely benefits to doing doing that. But I think the sort of local development environment is kind of the container that this tooling runs in. Regardless of where we were running our local development environment, we'd still want to write tools that improve our productivity. And that's kind of the fact that the big productivity gain came from writing a thing that builds a local development environment really, really quickly doesn't mean that all the other things that improve the efficiency of the team weren't worthwhile doing either. And that's kind of where we continue to write. Like the create new environment bit is probably like a quarter of the code base for this particular project, but the code base continues to grow every day. We have tools in place that will sort of talk to our data lake and set up data pipelines, which is it's kind of ClickOps or Terraform Hell, depending on pick your poison. We can kind of do that with an like interactive CLI kind of setup. So yeah, a lot of this is it's not 100% about the local dev environment. It just happens to be the most complex part of this, and I guess the most interesting part.
With 30 services, so 5 per developer per person, wouldn't it be, in hindsight, would it be better to stick with more of a monolithic approach? So you need less tooling around it?
Possibly. Possibly. You remember the team was significantly larger than it is currently, so choices are made when choices are made. There are advantages to the workload splitting, particularly how it runs in production. Our sort of services are not what you'd call microservices. They're more focused monoliths. So they are like, we'll have, for example, a content management service, which is a content management API that has a user interface as well as an API that's exposed to pull the data out of that. And we tend to not ever be working on 30 services at once. So it's not like a traditional microservices environment where every service is literally a single function, and you have to be across all of these things to make any change. You can get a fair way inside of one service if you want to. So yeah, don't know is I guess the complete non-answer to that question, but yeah, they are basically monoliths. They're just sort of ring fenced in a domain specific context.
Is that then like the development environment? Then like you got 30 odd of these that essentially more or less have their own Docker compose of their own like dependencies, creating DynamoDB. And then what you've done is essentially like where you've got a couple of these projects that all kind of relate to each other, you can then sort of run them all together, and they can find each other in their own way.
100%. Yeah. So it's all, it is kind of all Docker compose all the way down. There are some services that are common to it. Like every service requires a database. We just have one database container, and we just run all the databases in that one database container. Similar for cache, we just have one Redis container for local development because we don't need to have 50 of them. Also, when you pull down those initial repos, is what we would consider the core repos, the ones you're most likely as a developer to be developing in. It's not the whole constellation of 30. If you don't refresh your local development environment that often, I tend not to, you eventually get all 30 because you end up touching lots of different things as time goes by. But I think the default set's about 11 that come down, plus a proxy, plus so web server proxy, database, Redis, local stack, a few other bits and pieces that come along for the ride.
So how does your local dev environment know it's drifted from the production? Like, does it roll through all your repos and then do a git pull?
Yeah, so an earlier version of it did do that. An earlier version of it would kind of go through and sort of go, hey, what's changed? These days it's kind of so ephemeral, you just destroy the whole thing. So if you even suspect that things have drifted and aren't working the way that you expect, you just kill the whole thing and start again. It'll usually be pretty obvious that something's broken because you'll get an error on the page when you try and load something up because the service downstream has moved in a way that isn't conducive to the thing that you're currently working on. But yeah, in the past we have had it sort of just run a command, rip through all my it used to rip through all of the installed repositories, and unless you were on a branch other than main, it would do a git pull. So if you had cut a branch to work on something, it would leave that alone because it would assume that, hey, you're actively working in the branch at the moment. So yeah, very easy to do that. We just don't because hasn't been a major part of our workflow recently.
Yeah. How did you scale this in the sense of, did one developer go, I'm going to fix the new users onboarding, new developers onboarding, and eventually you had everyone on the team building tools, or did you just stuck at everyone to do it all?
No, it was scale that. it was a bit of that. There was a lot of pain, a lot of long-term pain in our Homestead environment. And if you've run Homestead with lots of things in it, that'll happen. I might be like hallucinating the actual events, but there was a chair flip moment where, some certificates on somebody's like immaculately modified Swiss watch of a vagrant environment got in a position where they couldn't easily update it and they had to nuke it. And we had been talking for a while about getting onto Docker, again, sort of eat your vegetables kind of thing. I don't think at that time we thought that it would get us any major benefits. We had started hiring a lot of people who were thinking that way anyway. So yeah, early experiments were basically, I want to run a local development in Docker, and Sail is not going to cut it for all the reasons that Sail won't cut it with our architecture. And then, yeah, built the whole thing out of a cobbled together set of like bash scripts and make files. And then we actually had a guy who would run around the office and fix everybody's local development environments because nobody else could understand it's broken and I don't know why. You've got to do this weird Docker thing here, eat your vegetables kind of. And then we decided, let's this is a good idea. Clearly, it's a good idea to put some rigor around this. But let's rewrite it in a language that everyone can understand and that everyone's really happy to work in.
It's a lot easier to sell. I'm just going to start working on this a little bit and see if we can make it more efficient. Then, hey, let's do the whole team in 2 months, retooling everything.
Yeah, 100%. We did have to do that retooling twice, though, because we first got everybody onto the bash version, and then we had to get everybody.
By then, so.
Yeah, I think one guy in the team was on the bash version for about 3 months after the PHP version went out. We just couldn't leave him off it. He said, no, it's working, it's fine, don't break it.
Loves bash. Everyone loves bash. It's great.
No, I think we just had to wait till it broke in a way that was sort of like, time to move on.
Everyone keeps moving services just to make sure it breaks.
Sure. Anyone else? Awesome. So I'm going to give this back to you. Thank you.